Good morning, everyone. Today, we are going to discuss about the significance of a problem statement where we are actually having the problem related tracking as well as the solution that we could find in order to mitigate the electricity and water wastage. So, we shall begin then. Over here, we can discuss about the ideas and the approaches about and through this particular project. And in this, we're going to discuss about the aim. The aim is to flatten the electricity demand curve, and the reasons are to prevent the power outages, grid failure, uncertain renewable energy fluctuations. The renewable energy fluctuation might be due to the solar panel issue during the rainy season, which might lead to higher electricity demand during rainy seasons. And we are going to further discuss it via the reference of the FD diagram later on. Let's move on to the solutions. In the solution, there are six major methods that we could adopt and one secondary. Let's look into that. Alerts. We could warn the customer to reduce the consumption whenever the electricity demand is going way higher than the limit and lower than the required essential demand. And the energy storage integration is a well adapted method that we could use to save the energy and use it when it's actually needed. Variable pricing. This particular methodology would motivate users to use the electricity whenever there is low pricing or lower demand for the electricity. And forecasting and adaptation. Over here, we're going to use the forecasting method in order to ad- calculate the variable pricing as well as also to alert the customer in advance. And flexible generation scheduling. We are actually going to include the various flexible generation resources like hydroelectric generation in order to meet the demands of the electricity during the time of peak as well as also to shift those demands to the fallen them. Later, spread awareness. Yeah, we need to spread awareness by using the various methodologies and also the effect which we are having on the nature, and the example for that with the carbon footprint. Ecoman. What we are actually going to do is appeal to the customer by using ranking and share status. And the ranking of the user would be based upon the various extent of the practices that they adopted. And as we already know, the people are more aware about the statuses, the social statuses. So it would be a lot better to include the eco-man perspective on it. And track. We're going to track the data from the meters, from the smart meter recordings from the household, as well as also the user interaction with the devices. Now, the industry. Industrial has been segmented to a different sector, and the reason behind that is because they are already well organized and their utilization of the electricity is well within the range of their own, because the power station itself. So the chances of reducing, or we can say reducing the power wastage would be quite low. But still, when we are actually going to segment that into small scale and medium scale industries, they quite be hard. That's why we are actually using the LLM model to do that. First of all, we are going to divide the production cycle into stages, and those stages are required to be fetched, and the methodologies to change, or we can say have any other alternatives to be adopted to be fetched to the LLM model as a query, and the output would be as an alternatives methods practices to mitigate the water wastages. And the small scale industry will adopt those methods because it will be profitable for them as well as also it would be make them eco-conservative. Now for the technology stack, we already know as it's a mobile application, then we're going to use further Python for the backend. LLM model, we are actually using LLM because the research materials, because the fine tuning could be well done with the LLM model too. Keras, to derive the time task mapping, over here we are going to do the behavior identification model. For creation of that, we are going to use the Keras model and Keras library and the TensorFlow. It's already going to provide supporting tasks to Llama 2 as well as also various of the precision and accuracy division and faster to store the data tables. Let's move on to the use case. The use case is going to be well defined with the DFD, but still, let's have a brief overview about that. Variable pricing, pricing the change with demand, time series clustering model to perform the cluster based on the electricity consumption. And then the supervised forecasting model will use the previous cluster that we have made from time series clustering model and identify the cluster that the user belong to. Now, the next behavior identification model. Over here, we are going to fetch the data on the metering system as well as also the behaviors, the user's interaction with the devices. That's how we're going to track the user's behavior. Now, tracking behavior will depend upon user's mobile interactions because we can't really track it other than the mobile interaction. Apart from the electricity consumption from the meter's reading, we are actually performing that as a baseline for it. Appeal to track the user's by status and rank as we already discussed. Industrial process to minimize the water wastage by using the LLM model. Facts of the day is just the one in which we're actually going to display them about the non-tracking waste and electricity conserving practice on a daily basis, like a quote of the day. Then the next is about syncing the notification with users' behavior and lifestyle. That's to be getting the user's feedback on timely basis. Then describing a dependency is a showstopper here. We're going to talk about what the dependencies and this particular project is dependent upon. And those are fine-tuning of the LLM model. Why is that? Because we actually need to just work upon the water and electricity related data. That's why. And the variable demand. As we know, the demand of the electricity, depending upon various situations like special events, weather, and holidays, will vary. And due to that, we need to include those factors into our ML model too. And the time complexity as well as its accuracy. These are always the required factors whenever we are concerned with the creation of a model and also its scalability. And it is quite a formidable task. And we are aiming to cater the needs of 10,000 users at a time with a time limit of 10 to 1 hour, 10 seconds to 1 hour. Now the showstopper. Over here, there is a variable generation. What does that mean? Is that we do have power outages, maintenance, as well as the renewable energy resources. To that particular factor, it will be a lot more difficult to, we can say, divide our sources, or we can say map a PML model just based on the user behavior. Because if a power outages or maintenance comes into the play, then we can't really have that particular day or the data on those certain days to be included in it. Now, the grid stability. Over here, as the fluctuations could be vary among the electricity demand, could be higher, could be low, and due to those sudden fluctuation, will have impact on the machines and will further lead to the grid stability itself. Now, the integration of the renewable energy. As we already discussed with an example of solar panels during rainy season, that during rainy season, solar panel would be particularly useless and the demand of the user will totally dependent upon the electricity from the government power plants. And due to that reason, the electricity demand would during the rainy days would suddenly spike out and will suddenly lead to grid instability and thus the problem. Now the need for the appliance specific readings is to actually have a better understanding about the behavior interactions and the behavior data of the users. And also, as the fourth point, pretty much have a connection with the fifth one, the mobile interaction environment data. That's why we need for the appliance specific readings. Now let's get a better understanding with the user DFD diagram. Over here, the user will be segregated into two parts, household and the industrial. Now let's just because to talk about the all the specific activities for household. Over here, we're going to focus on the appeal part as we discussed that we are going to tell about the eco status, ranking, and the sharing ways. And on the sending notification would be about syncing with the users because of behavior and then sending those notifications to get the user's feedback. Then tracking behavior. We're tracking the behavior by the mobile interactions that they are having, as well as also various other smart automation devices that they may have and will use their mobile devices to interact with. So it is totally dependent upon the mobile devices altogether for getting the behavior of the user, particularly on their daily routine. Segregating, or we can say we are not including the smart meter reading on checking the behavior. We will do it on the basis of that laterwards by using the clustering model. Now the model updation. Over here we're going to update it depending upon the daily smart meter reading towards the clustering model as well as also the forecasting model. Now those reading meters are also stored in the meter database. And what we are doing in the clustering model is pretty much going to create clusters from the smart meter reading and storing in the cluster database about those visual clusters that we are going to form. And these clusters are going to be used to identify as well as predict the various clusters that this particular user is on. Now, this behavior identification model is going to use the behavior data from the user as well as also the clusters that we are going to form, and will check whether it belongs to this particular user or not. And by that, we are going to form what the behavior and how the user is using their devices or electricity and meeting those demands. And it's quite crucial to, if you can say, check their regular data and use it in the appeal status. If we can't really have regular behavioral changes mapping, then we can't really check, or we can say do this particular appeal operation better perfectly. Now the variable pricing is quite important because this is the only monetary benefit that a particular user will get, and it's quite important to look into it. We need to first of all get the cluster that this user belongs to, calculate the differences, and calculate the pricing. That's all. And the time complexity of variable pricing will be on for each user. It won't take that long because we are actually taking from the database itself, so it will be quite fast. And yeah, the only complexity that will have effect on it will be the clustering as well as the forecasting. Now let's just move on to the industrial sector. As we discussed, it will break down into various stages, those production cycles, and then we are fetching the information about each stages while using the LLM model, and then what electricity utilization methods is supposed to be suggested to the user. And most likely the small scale industry will adopt those methods too. The smart meter reading that is needed to be used in the cluster model is going to be the KOL 15 minutes final multimeric readings. Over here, the smart meter readings are supposed to be given at 15-minute interval for each and every other days for a total of 60 days. And there are a total number of 768 consumers, and we are going to calculate and test run on the basis of this particular data. And the second data is going to be the household power consumption that is just used to test what the various other parameters and features are being used apart from just a simple global active power. And the electricity consumption is just going to help in order to understand the various consumption of the electricity on various other fields or sectors like nuclear, wind, hydroelectricity, oil, gas, and coal, petroleum. Now they just at TKX. Over here, we are going to have the different production electricity consumption in various other different regions like Punjab, Haryana, on the basis of states. The long data is just a vertical representation of the same, while having the regions, latitude and longitude of the various states itself. Now, the end of discussion about the data sets. Now we're going to move about the model that we are going to use. And over here is the clustering electricity model. Let's discuss about it. This is the time series clustering model where we are just going to have create clusters on the basis of the data that we are going to provide. Over here, the extract data is actually indicating the KOL minimum data, which we have actually discussed about over here, minus final merge data. And we're using the DTW algorithm to calculate the time series distance and the Euclidean k-means to actually have the k-means clustering algorithm to find those clusters that we needed. And we could see the time complexity over here, as it's just going to take around 10 seconds to calculate for an overall of 1,000 users. Yeah, it might not be that accurate, but the accuracy is going to be created a lot further after further analysis on the part. Now we are going to discuss about the same method by using KNN in order to use it for time forecasting by using the same cluster that we actually have used. Now, how are we going to do that? First of all, we are going to have DTW algorithm to get the distance between two time series and KNN to identify for that particular user which cluster that user belongs to. To be noted, all the remaining aspect of the project will be completed later on, and we have completed certain aspect of the project, and the rest of those would be added on the future scope of the project. Thank you.